Today we're going to look at the Arduino and how to best model the Arduino. We're going to use a software, a web app called TinkerCAD. This comes from Autodesk and it is used for making prototypes before you actually build the real thing. So we're going to scroll down to our TinkerCAD once we log in, and we're going to select circuits. We're going to create our first circuit design. So the reason why we use AutoCAD or a computer-aided design is so that whenever we build something with CAD, we can test it, make sure it works without putting the effort in of making physical components and using physical components and even breaking those physical components. So this allows us to test in a safe environment, if you will, and see what works and what doesn't work before we either burn something, short something, or just waste time on something. So we're going to start by just looking at our environment. So up here in the top left, we have our name that's auto-assigned. We have up in the top right, code. We can access our code if we need to, but we don't have anything to code right now, so we're not going to do that. We have our start simulation button, which is pretty much just to start the simulation. We have a share. The start simulation is pretty much just the on button for us. We have the share button. And then down here we have all the different components of it. So what we're going to do, and what we'll be working with here in the future and today, is working with the Arduino Uno R3. So we're going to scroll down and select the Arduino Uno R3, and we're going to drag it into our environment. So once you're there, you can select it and move it around just by clicking and dragging. You can zoom in by scrolling towards you, zoom out by scrolling away from you. You can press M. Okay, apparently you can't press M on this, only the components. You can press R, I know that. You can press R to rotate, and we're going to rotate it about like this. Okay, so let's take a tour of our Arduino Uno for a second. I'm going to rotate it just a little bit more. There we go. So up here on the top of our Arduino, or if you're looking at it normally on the right side, we have our digital pins. These control digital elements, and we'll be using those for coding and programming later on. You also have some that are pulse width modulation. That just means that you can control the voltage going to it, so you can use a digital pin to dim an LED. Okay, moving downward, we have on the right side our analog in, while digital is a block wave, so it goes like boop, bop, beep, boop, bop, beep. Let me see if I can get it frame. It goes like that, or it's a square wave as some call it. Analog in is a regular wave as we know it to be. So then we have the one that I'm interested in today, which is the power rail. The one that we're really interested in today is the ground and the 5-volt. So we're going to build a circuit using just the ground and 5-volt. There will be no programming involved, and we're just going to see if we can build a normal circuit using the Arduino as a power source. It's going to be pretty straightforward. So let's go ahead and zoom out. Okay, I'm going to rotate my Arduino using R such that it looks like this. Our power values, they're upside down, but we can still read them because we're smart. So let's go ahead and bring in a breadboard. This is in our capacitor menu, not capacitor component menu. So let's go ahead and drag that in. And it's pretty big, so I'm going to zoom out. Okay. Whenever you select something in TinkerCAD, it's surrounded by a blue highlight. It's kind of hard to see down on the Arduino because the Arduino itself is blue, but that's the way it is. So we're going to select our breadboard. I'm going to rotate it about 90 degrees. I'm going to bring it down here to where I know where it is. Right, anytime that we're building something with a breadboard or with the Arduino, it's optimal to build it first with TinkerCAD or some other CAD software because we want to minimize risk and just play around a little bit. What happens if I do this? Does it work? Does it not work? How interesting. Let's find out. So let's take a look at our breadboard. If we hover over the positive power rail, the entire power rail becomes highlighted. What that means is if I energize one port on this power rail, the entire power rail is energized and it all becomes a source of positive electricity, if you will. Positive, it's semantics. Then if I hover over the negative rail, the entire rail lights up as well, and that whole thing can become the ground potentially. Now, if I scoot over into the meat of the Arduino, which is A through J, then 1 through 30 in this coordinate grid, if I hover over, say, row 1, the entirety of row 1 becomes highlighted. What that means is if I place something on A1 and I ground it to the negative rail, this whole row is now a ground. If I take something from row 2 and I place it on the positive rail, this whole row 2 is now positively charged. So the rows, they carry horizontally. The power rails, they carry vertically. Let's go ahead and Control Z that. Okay, so what we're going to do is we're going to set up a very simple circuit. We're going to use a 5-volt, a ground, another jumper cable, and a resistor along with an LED, and that'll be our circuit. So we are going to zoom in. I'm going to start by taking my ground and dragging. I'm going to click and then drag all the way over to my negative terminal where I'm going to press, and that will connect the jumper cable. Almost forgot my words there. Then I'm going to take the 5-volt, I'm going to plug it into the positive terminal. So now I have my negative terminal is my ground, and my positive terminal is my 5-volt. Okay. So now I want to take the ground and the 5-volt and I want to transport them to the middle of the breadboard where all the circuitry is actually going to happen. So I want to jump them from the terminal to the board, hence jumper cable. Kind of like how you have jumper cables in your car. These are the same concept, just a little bit smaller, a lot smaller. Okay, let's say that I want to not have all my cables the same color because I'm not stuck with them. So what you can do is you can click on a cable. If the cable is blue in TinkerCAD, then it is selected. And you can also tell it's selected because it'll have these two dots at the end. For example, our 5-volt's selected now, but our ground isn't. Our ground's selected now, but our 5-volt isn't. So we can select one, and we can go up here to the top toolbar, and I'm going to click on this color where it says wire color. I'm going to turn my ground black, as is the general consensus. My 5-volt, I'm going to turn red. Okay. So now my ground is a different color than my 5-volt, and my 5-volt is a different color than my ground. I now have a colored definition of ground and power. Cool. So let's go ahead and let's make a circuit. So my wire is still red. That means it's still positive. I'm going to go ahead and change that to black for negative because we're about to jump the ground over into the breadboard. So let's go ahead and select this one right here. I'm going to jump that to A4. Now, what that means is all of row 4 is now a ground. Okay? And then I'm not going to use a cable for this next part. Instead, I'm going to use a resistor. So I'm going to bring in a resistor. I'm going to rotate it 90 degrees. And it's going to connect to the positive power rail. And I'm going to hook it up to A5. There we go. Now, if we zoom in here, we'll see that it brings up a context menu. And in that context menu, we can rename it. We can say that, hey, this is resistor A. And we can also change the resistance. So it is automatically in kilo ohms. We're going to change it to regular ohms because we need pretty low resistance for this. So in the drop-down menu, just select regular ohms or just omega. And we're going to change the value from 1 to 220. So this is now a 220 resistor. Let me see if I can zoom back out for us. There we go. Okay, so what I have now is I have positive flowing through my resistor, and I have negative flowing out through my jumper cable. Now, all told, this is an open circuit because I have a ground and I have a positive. What I need to do is I need to bridge the gap in order for something to happen. So what I'm going to do is I'm going to take an LED, I'm going to drag it in here, and let's rotate it 90 degrees. Okay? And what we're going to do is we're going to bridge the gap between these two. So I'm going to put my LED right here. And you can change the color if you want. Let's go with green. I like green. Okay. And let's see if this works. So what we do is we press start simulation and it turns on. Wow, incredible. But curiosity, are LEDs directional? Well, let's find out. So I'm going to stop my simulation. I'm going to select my LED and then I'm going to press M to mirror. And as you can see, what that does is it flips our LED. It takes the long leg, which we had originally as the anode, and it puts it on top right here. So let's see if that works. What that means is we're hooking the anode up to the negative and we're hooking the cathode up to the positive. And nothing works. Interesting. So let's stop the simulation and mirror it again. And here we go. So what we see here is that the anode connects to the positive and the cathode connects to the negative. Opposites attract, all that jazz. So LEDs are directional. So whenever we build an LED or we put an LED in a program, not a program, but a build for an Arduino, if it's not working, the easiest thing to do is just take it out, switch it around. And if that doesn't work, then you have a problem. All right, so there's our simulation done. What we're going to do is we're going to use this simulation in order to build this circuit using an actual Arduino kit. Let's do that. Here we have all the components we need to take our CAD model into the real world. First up, we have our Arduino. It looks a little bit different from what we have in the CAD model. This one has a little bit more stuff on it, but it functions generally the same. Again, we're going to be focusing right here on the ground and the 5-volt. Okay, so here's our breadboard. This one is a little bit bigger than the breadboard we had in the TinkerCAD. That's okay. We're only going to be using about this much right here. Here's our LED. I chose the green one because green is the best color of LED. We have our 220 ohm resistors. Many times, all the time that I've run into, your resistors will come in packets and they'll be labeled with their resistance. And then we have 3 different colors of our jumper cables. We have red, black, and white. And then finally, I have my blue power cable hooked up to a computer off screen. Okay, so we're going to start by looking at our Arduino. Okay, let's connect our black cable to the ground right here. And we're going to connect our red cable to the 5-volt. Now, normally you want to connect your 5-volt to the your power to the breadboard first, and then connect it to the Arduino once it's all done. But our Arduino is not powered right now, so I'm not too worried about it. Okay, then I'm going to take my ground. I'm going to hook it up to the negative power rail. To the negative power rail right here. I'm going to hook up the 5-volt to the positive power rail. I'm going to scoot this over a little bit. Negative will go right here. Sometimes you're stubborn. And positive will go right here. Okay? So then we're going to take our resistor. These come out pretty easy. You just kind of pluck them out. You bend it such that it's a U shape. And we're going to jump our resistor from our positive terminal. Let's jump it to about, let's do, this right here is J. So let's do J4. Okay. So now, once we plug this in, this entire row right here, is positive. So we're going to take our jumper cable, plug it into the negative power rig, like so. And I'm going to put it directly next to on J5, such that they are right next to each other. That's going to make it a lot easier for our LED to bridge the gap. Okay. So then I'm going to take my LED. I'm going to put it long leg on in any of these holes. See if that will focus. Long leg on any of these holes right here. Short leg on any of these holes right here. Because remember, this row is now charged positively. This row is now, we could say, charged negatively. So I'm going to just pop it right there. And now let's see if it works. There's no code involved in this, so we shouldn't have a problem about running code or anything. If we plug it in, oh, might help if I plug it in right. To plug it in, we get our LED turn on because our Arduino has power and it's feeding that 5 volts to the LED. So this is just a really simple circuit, and we'll have more projects as we go on. Alrighty, have a good day.